Good morning, students. This is Anjali, Assistant Professor, Department of CAC, AIML, IARE, Hyderabad. Today's our topic is Definition and Terminology on Basic Mathematics and Probability for Data Science. In previous topic, actually we have discussed about the definition and terminology on totally mathematics. We have seen different notations, different set theory, matrix, vectors, everything we have seen in previous topic, but now in our today's topic we will see the probability. So let's see one by one. Probability. What is meant by probability? Just if we will consider, or if we that word will become in mind, then we can just say that probability means chances. We can say it's just chance, possibilities. So simply we can, the probability is an intuitive concept. We use it on a daily basis without necessarily realizing that we are speaking and applying probability to work. So we can say that the probability is just a concept. Possibilities concept. That concept is totally depends on possibilities. How much percent chances to get that particular output. So generally every day, on daily basis, we are realizing that speaking and applying generally depends on our probabilities, depends on our possibilities, depends on our chances. So we know that our life is totally uncertainties. And we don't know the outcomes of the particular situation until it happens. So really, we can take like an example. Will it rain today? We don't know whether it will be rain or not. There is just chance. There are chances that of 50-50%. Then next one, will I pass the next math test? So again there is a chance. There are again two possibilities, either pass or fail. So again there is a 50-50% chance to get pass or fail. Then will my favorite team win the toss? There is also chance. There is also possibilities. We don't know which team will win the toss. Then will I get the promotion in next 6 months? So every question is denoting, is representing that there is only chances. We can't give the surety of that particular activity will happen. Really. So just these things can come under your probabilities. So all these questions totally showing that uncertain situations. These are uncertain situations. So there are some aspects which are including in the probabilities. First one is that the experiment. What is meant by experiment? So just experiments also are the uncertain situation which could have multiple outcomes. Whether it rains on a daily basis is an experiment. So experiment is just uncertain situation, whether it will rain, whether you will pass or fail. So these are the situation. And for that, there are so many outcomes, different outcomes also. So next one is the outcome. What is meant by outcomes? If we will get the realized what is meant by outcomes, the outcome means in single word we can say the result. We can say it's a result. Outcome is a result of a single trial. So if it rains today, the outcome of today's trial from the experiment is it rained. So our situation is that just will it rain today? This is our situation. So according to this, if we consider this situation, if we consider if it rains today, so the outcome will be like it rained. Then next one is the event. Event is one or more outcome from the experiment. It rained is one of the possible event for this experiment. So event means that for that particular outcomes you will get the so many outcomes. That particular experiment you will get the so many outcomes, so many results. So it rained. It's one of the result. It doesn't rain. It's another result. So that means there are different events for particular situation. Next one is the probability. Again, probability is a measure of how likely an event is. So if it is 60% chance that it will rain tomorrow, the probability of outcome it rain for tomorrow is 0.6%. So probability means just a measure of how likely an event is, or we can say the chances of happening that particular event. So for example, if there is a 60% of chance that it will rain tomorrow, that means we are giving the chance. We are predicting that it will rain tomorrow, but not today. So definitely there is a chance like 60%. So that probability is 0.6. It rained for tomorrow, that is 0.6. Now, why do we need the probability? Actually, in an uncertain world, it can be immense help to understand chances of various events. You can plan things accordingly. We know that nowadays so many uncertain situations are there, and if in front of you there is uncertain situation, so that probability can help to know or to chart, to understand what are the different events for the particular situation. And if it's likely to rain, I would carry my umbrella. And if I'm likely to have diabetes, on the basis of the food habits, I would get myself tasted. So again, there are different situations. One situation is depends on rain, and another situation is depended on totally on food habits. So if it's a rain, then definitely I will carry my umbrella. But next situation is, if I got the diabetes, then I would get myself tested. So these are situations, these are the probabilities. Next one is, if my customer is unlikely to pay me a renewal premium without a reminder, I would remind him about it. If any customer wants to renew his or her premium, so definitely at that time, I will remind him. So these are chances. That's why we need to use the probability. Probability will help to know what are the chances of particular happening of the events, to understand the different chances of the events. So it will be easy to to predict the events, to predict the outcomes. Now, how do you find probability in statistics? First, divide the number of events by the number of possible outcomes. If any particular situation is there, definitely there will be number of events. There will be available number of events. And now you have to divide the number of events by your possible outcomes. How many possible outcomes are there? So you have to find out. Then after determining the probability event, its corresponding outcomes, divide the total number of ways that the event can occur by the total number of possible outcomes. So here, after determining probability event and its corresponding outcomes, you have to divide your total number of ways the event can occur by the total number of the possible events. And now, for example, rolling a die once and landing on 3 can be considered one event. Now, probability generally deals with occurrence of the random event. So, there are 4 rules of the probabilities. First one is addition rule of the probabilities. Addition rule means just probability of A or B is equal to probability of A plus probability of B minus probability of A intersection B or an intersection. Then next one rule is multiplication rule of probability. Again, probability of A and B is equal to probability of A into probability of B divided by A, or we can say probability of B into probability of A divided by B. Then next one is that complement rule of probability. Complement rule means just P not A is equal to 1 minus P of A, or we can say P of A is equal to 1 minus P of not A. Then total probability rule, the sum of the probabilities of all possible outcome is 1. Then in the basic concepts of the probability, there are that basic concept is containing the procedure, event. The procedure is an act that leads to a result. Now, for example, throwing a dice or revisiting a website. It's just procedure. Procedure means just you are doing something by stepwise. Just for example, throwing a dice. This is also procedure. Visiting a website. This is also procedure. Then event. Event is a collection of the outcomes of procedure, such as getting a heads on a coin flip or leaving the website after only 4 seconds. So just event is a collection of outcomes of the procedure. So we can consider like getting heads on a coin flip or leaving your website after only 4 seconds. These are event. Then simple event is an outcome or event of the procedure that cannot be broken down further. Rolling 2 dice can be broken down into 2 simple events. Rolling die 1 and rolling die 2. And the sample space of procedure is set of all possible simple events. Your sample space means possible events you should be skipped. Now, for example, an experiment is performed in which coin is flipped 3 times in succession. So here you have tossed 3 coins, coin 1, coin 2, coin 3, and definitely after flipping a coin, you will get the different outcomes. Now you have to find out what is the sample size for this experiment. This is your experiment, flipping a coin. Flipping coins is your experiment. So, when you will flip the coin, on this basis, you will get different possibilities at the same time with these 3 coins. So, there will be chance to get the 8 possibilities. So, how we will get the 8 possibilities? Like head, tail, then head, tail, head, tail, head, tail. Then all 3 coins will contain the tail. 2 coins will contain tail and 1 coin will contain head. Then 1 coin will contain the tail and 2 coins contain head. And next tail, head and tail. So these are the possibilities outcomes. So that means Here sample space, size of the sample space will be 8. So the probability of event represent a frequency, or we can say the chance, possibility that your event will happen. Now the notation, if A is an event, P of A is the probability of the occurrence of the event. Now we can define the actual probability of event A as follows. Now what is meant by the probability? What is the formula for the probability? Probability of A is equal to number of ways A occur and the size of sample space. Now next one is that frequentist approach. What is meant by frequentist approach? Actually, in frequentist approach, the probability of an event is calculated through the experimentation. Here, we will perform so many experiments, and on that basis, we will calculate the probability of the event. Now, it uses the past in order to predict the future chance of the event. And here, we have to predict our outcomes on the basis of what happened in the past. So basic formula for the frequentist approach is that P of A is equal to number of times A occurred divided by number of times the procedure was repeated. This is your frequentist approach. So basically, we observe several instances of the event and count the number of times A was satisfied. So the division of these numbers is approximation of the probability. So in frequentist approach, what will happen? You have to calculate your probability of the event on the basis of the experiment. How many times you are repeating that particular experiment, and that after that you have to predict your event, future event on the basis of previously got your outputs. So on that basis, you have to find out the frequentist approach, and frequentist approach will contain frequentist approach is equal to number of times your A event occurred and divided by the number of times you have repeated your procedure. Then Bayesian approach. The Bayesian approach differs by dictating that probabilities must be discerned using the theoretical means. So, using the Bayes approach, we would have to think a bit more critically about events and why they occur. Now, here in Bayesian approach, we have to think why this particular event occur. You have to think. As in frequentist approach, you are totally dependent on particular experiment. But here, you have to think why this event occur, and neither methodology is 100% the correct answer all the time, and it comes down to the problem and difficulty of using either approach. So whenever you will use the Bayes approach, mostly it will give the sometimes incorrect answer. So we can't trust on the Bayesian approach totally. The crux of the frequentist approach is the relative frequency. And the relative frequency of an event is how often an event occurs divided by the total number of observations. Now there is a difference between frequentist approach and the Bayesian approach. First, setup. In frequentist approach, your theta is unknown and fixed. But in Bayesian approach, your theta will show as a random variable. Then what do we want? In frequentist, your theta is the base estimate. Theta cap is your base estimate of the theta. But that is also fixed. That should be the fixed. And P of theta given x comma y. The posterior distribution dictated by the data in Bayesian approach. Then what do we need? In frequentist approach, we need to build a model using the data xy coordinates for determining the theta cap. And in the Bayesian approach, we have to use the data determine P of theta as a prior probabilities. Then how we do it? OLS is equal to OLS theta cap is equal to covariance y comma xi divided by variance divided by xi. Your logarithms of the x comma theta, that is showing the likelihood function, and the p of theta x comma y, variance logarithm x comma y theta into p of theta. That means we have to find out here p of theta. Now inference is showing that h naught theta is equal to 0 ha. This is showing your hypothesis, and theta not equal to 0. And here p value is the probability that theta is greater than covariance. So p of theta greater than theta covariance given x comma y can read from the posterior probability. So this is the difference between the Bayesian and the frequentist approach. Now compound events. Sometimes we need to deal with the 2 or more events, and these are the compound events. That means that particular thing, a particular experiment will contain so many events, more than 2 events. That's why we will say it is the compound event. And the compound event is any event that combines 2 or more simple events. So when this happens, we need some special notations. So probability that A and B occur is P of A intersection B is equal to, we can write as a P of A and B. Then the probability either A or probability or B occurs. So at that time we can write as a P or P of A or B. Then conditional probability. The conditional probability refers to the chances that some outcomes occurs given that another event has also occurred. So here conditional probability is showing that there will be some chances of getting some event which are totally based on some conditions. So it is often stated that probability of B given A and is written as probability of B given A. So where the probability of B totally depends on that of A happening. That means A will happen, already happened, and you have to find out the probability of B. So conditional probability can be contrasted with unconditional probability. So probability is classified as a conditional, marginal or joint. And this generally Bayes theorem is your mathematical formula which is totally used for calculating your conditional probability. So conditional probability is totally depends on condition. Here's one of the condition will be already happened and another condition will happen. Now there is a conditional probability formula. P of B given A, probability of B already A happened, is equal to probability of A and B divided by probability of A. Or we can say probability of A already B given probability of A and B divided by probability of B. So this is the formula of the conditional probability. P is your probability, A is the event A and B is the event B. Probability A given B is that it is showing that probability of A event A occurring, but already event B occurred. Now for example, you drew a red car. Now what's the probability that it's a 4? So we have to find out red card, but we have to find out that card should be the 4. So probability of 4. Color is saying red. We know that red color are 26. In pack of cards, 26 red, 26 black. So out of 26, There are again 4 number cards. 4. So 2 will be red, 2 will be black. Out of this, we have to find out the 4 of red. So that means we can find out 2 out of the 6 and our probability will be 1 by 13. So out of 26 cards, there are only 2 4s. So 2 by 26, that is 1 by 13. It's our probability, it's our chance, it's our possibility to get the 4, red 4. Now, marginal probability. The marginal probability, the probability of an event occurring P of A is in isolation. It may be thought of as an unconditional probability. So marginal probability is totally depends on your unconditional probability and it is not conditioned on another event. It is not depends on another event. So for example, probability that a card drawn is red, that is probability of red. So definitely there are 52, there is a 52 pack of the card. And out of the 52 cards, 26 are red and 26 are the black. So our chance 26 divided by 52, that means we can say the 50% chance to get the red card. So another example, probability that card drawn is a 4. So again probability of 4. So that will be 1 by 13. Now conditional probability calculator. The conditional probability calculator is online tool that will calculate conditional probability. So it will provide the probability of first event and the second event occurring. The conditional probability calculator saves user from doing mathematics manually. There is no need to do mathematics manually. Conditional probability calculator is your online tool and by using that online tool, we can calculate the conditional probability and we no need to do manually mathematics. Now prior probability. The prior probability is the probability of an event occurring before any data has been gathered to determine the probability. So prior probability is totally depends on event occurring before gathering your data. And that is the probability as determined by the prior belief. So prior probability is component of Bayesian statistical inference. Now, conditional probability of mutually exclusive events. As per the probability theory, when we talk about the events that cannot occur at the same time, we are talking about the mutually exclusive. In mutual exclusive means those two conditions, those two events will not happen at the same time. To put simply, just we can take the example, if event A has occurred, event B cannot occur. So in that case, most of the time your probability will be always 0. So probability of B given A or happen A, that will be 0, or probability of A if happen B, that can be 0. Now independence. Two events are independent if one event does not affect the outcome of the other. That is, probability of B given A is equal to probability of B and probability of A given B, that is probability of A. So whatever it will happen, whatever event you are getting, both events have different outcomes, but if event A is increasing, it will not affect on the event B. If event B is increasing, it will not affect on event A. So both events are independent. If two events are, both events are independent, then we can say that probability of A intersection is equal to probability of A into probability of B given A. That means we can say probability of A into probability of B. So in short, we can say that probability of A and B is equal to probability of A into probability of B. So there are some just examples. It was raining in San Francisco and puppy was born in India. There is no relation between two these events. So raining in San Francisco and puppy was born in India. These two events are totally different. So these events are not affecting on each other. So we can say that both events are independent. Flip a coin and get heads and flip another coin get tails. So definitely if you have two coins, it will not affect. It will give the different events, but it will not affect. None of these pairs of the events affect each other. Every event is the independent. This is called independence probability. Next one is that complementary events. Complementary events are two events that exist such that one event will occur if and only if the other does not take place. So this is complementary events. For two events to be classified, complementary events must be mutual exclusive and exhaustive also. So sum of the probabilities of the complementary events must be equal to 1. Like P of A plus P of A minus A complement should be 1. So here complementary events can take place only when there are exactly two outcomes. Then collectively exhaustive event. In probability theory and logic, set of events is jointly or collectively exhaustive if at least one of the event must occur. In collectively exhaustive events, at least one outcome should get. For example, when rolling a six-sided die, you know that event will occur. 1, 2, 3, 4, 5, 6. These are the events. So balls of a single outcome are collectively exhaustive because they encompass the entire range of the possible outcomes. We are keeping this range in the set. These are the possible outcomes. So that means this is your collectively exhaustive events. Then how do you know if events are collectively exhaustive? Generally in probability, set of events is collectively exhaustive if they cover all the probability space. Probability of any one of them happening is 100. For example, in collectively set we can take that rolling a die, it will contain 1, 2, 3, 4, 5, 6. So sometimes you will get at least one output you will get. So that is your collectively outcomes. Then exhaustive events. Exhaustive events are set of events in sample space such that one of them compulsorily occurs while performing the experiment. In simple words, we can say that a possible events in sample space of experiment constitute exhaustive events. So exhaustive events are just set of the events in sample space such that one of the outcome definitely you will get. And that possible event in sample space experiment that constitute your exhaustive event. For example, while tossing an unbiased coin, there are two possible outcomes, head or the tail. Definitely these two outcomes are exhaustive events, head and tail. These are two outcomes only. Out of this, at least you will get the one output. So these are the exhaustive event. Now let's understand some basic example. About the mutual exclusive exhaustive event, we can understand we have understood already the examples of mutual exclusive exhaustive events. Now exhaustive events Venn diagram. Now there is a diagram showing entire sample space of the experiment AI. I belongs to 1, 2, 3, 4, 5, and there are some possible events like a S. In S, the possible events now we have A1, A2, A3, A4 and A5. These are your exhaustive events, as one of them will definitely occur whenever the experiment is performed. Now the diagram shows exhaustive events that are not mutually exclusive, as these events intersect with each other. Now which implies more than one experiment can occur simultaneously. So this is the just diagram. Now mutually exhaustive events. The exhaustive events that are mutually exclusive are said to be mutually exhaustive events, collectively exhaustive events. Such events cannot occur more than one at the same time, and one of them definitely will occur wherever the experiment is performed. For example, rolling a die. Again, we can take rolling die. 1, 2, 3 possibilities are 1, 2, 3, 4, 5, 6. So this is the mutually exhaustive. No two numbers can appear at the same time, and one of them will definitely will appear. Now when tossing a coin, two possible outcomes like head, tail, these are also two mutually exhaustive events, and they cannot occur at the same time, and both consist of sample space. Now random variable. The random variable is variable whose value is unknown or function that assign the values to each experiment's outcomes. This random variable is just a variable. This value for that particular variable is unknown. We don't know the value of the particular event, that particular outcome. So random variable can be either discrete or the continuous. If it's discrete, means it will contain the specific value, and if that random variable is continuous, that means it will contain the range like 1 to 5, 10 to 20. This is showing the range. So if your random variable is a continuous, then it will contain the range, and if your random variable is the discrete, then it will contain the specific value. And the use of random variable is mostly common in the probability that and statistic they can use to quantify outcomes of the occurrences. And the risk analysts generally use the random variable for estimating the probability of adverse event occurring. And random variable is totally differ from algebraic variable. This variable in algebraic equation is a known value that can be calculated. In algebraic equation, that random variable is there, so it's possible to calculate the unknown value. But in random variable, it's not possible to find out the particular value, because random variable also have two types of the random variable, discrete and a continuous. If it's continuous, means it will contain the range, and if it's a discrete, means it will contain the specific value, particular value. So for example, the equation is that 10 plus x is equal to 30. Here we can calculate the value for the x, and that value will be the specific value. So that specific value will be 3. And on the other hand, again, random variable has a set of values, and any of these values could be resulting outcome, as seen in example the dice above. Now discrete random variable. Discrete random variables take on a countable number of distinct values. Consider an experiment where coin is tossed 3 times. I already told that if your random variables are the discrete, then that value will contain the specific value. That values are countable. Your coin is, for example, coin is tossed 3 times. So definitely that outcomes are countable. For example, if x represent the number of times that coin comes up heads, then x is discrete random variable. that can only have the values 0, 1, 2 or 3 from no heads in 3 successive coin tosses to all heads. So no, the value is possible for the x. So these are the particular values for the particular variable. Now continuous random variable. Continuous random variable can represent any value within the specified range or the interval and can take infinite number of possible values. I already told that the continuous random variable will contain the range, it will contain the variable, and we don't know what will be the range. It depends on the situation. For example, continuous random variable would be an experiment that can involve the measuring the amount of rainfall in city over here and average height of random group of the people. So it will contain the only range. We can't specify the particular value. We can't denote the particular value. So join in later if y represent random variable for average height of random group of 25 people. You will find that resulting outcome is continuous figure. Height may be 5 feet, 50.1. So that thing can change continuously. So it depends on the situation. So it's showing the infinite number of possible values for the height. So these are the continuous random variable. Now what are the two kinds of the random variable? The random variable have two types. Those are discrete random variable and the continuous random variable. Discrete random variable means it is a countable number. It will contain the specific number like heads or tail, playing cards, side of the die. These are the countable numbers. Then continuous random variable, it will contain the infinite number of potential values. It will be uncountable number such as average rainfall in the region. Next, mixed random variable. The mixed random variable combines elements of the both discrete and the continuous random variable. Now, how do you identify the random variable? Actually, the random variable is one whose value is unknown prior or else is assigned random value based on data generating process or mathematical function. So, generally in random variable, that value will be the unknown prior. And that most of the time we can assign that random variable based on that data. Then why are the random variables are important? Actually, the random variable produce some probability distributions, and that the probability distribution totally will be based on your experimentation, your observation, or we can say data generating process. Now, and in this way, it will allow to understand world around the sample of the data, and by knowing about the likelihood and that specific value will occur in real world. So that's why the random variable is very important. So these are the references. You can go through this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.